Now the next topic is one that also gets pretty direct application in Physics 30. That was using spectroscopes, or how they're used, to analyze the distribution of energy and figure out the surface temperature of a star. That's because things at a particular temperature will emit a particular collection or profile of electromagnetic radiation. So this is called the black body curve. This is why stove elements turn red as they heat up, and stoves usually don't get this hot, but if you do a campfire, you'll see it starting to turn white hot. That's because that spectrum is shifting. So our sun, if you view it from outside the atmosphere, is actually white, not the yellowish color for the light that penetrates the atmosphere. And it will absorb energy, so we'd have black lines in the spectrum. Now, Doppler shifting means that the source of a wavelength or of a wave is moving. If it's moving away from you, then it increases the wavelength of that light. If it moves towards you, it decreases the wavelength of that light. This is why if you're watching a race on television, you see a car drive by the camera, you hear that sound. That's the sound of the engine, which is actually a consistent sound that is getting shifted as we go through. So when you know the emission spectra of a particular star or of a particular element, and then you look at a star in the sky and see that the black lines corresponding to the emission spectra have all shifted to a different wavelength or frequency, then you can use the Doppler shift to backtrack and figure out, well, how fast is that star moving relative to us? And figure out what the speeds of these stars actually are.